In this problem, we have to reverse the bits of an unsigned integer. And it's very clear from this title that we have to reverse the bits. So let's say our integer is represented in just 3 bits. I cannot draw 32 bits here. So what we have to do, this least significant bit should become most significant bit. So this comes here, the second one comes here, and this one comes here. So these are reversed. So how we will do it? We will look at a few ideas. We will implement one of the ideas or two of them. And we will also see some more ideas which can be used to reverse it. So let's start with a trivial solution that would be good enough. That would be O1 time and constant time, not dependent on the input size. So here, let's say this is the input integer. So here we have 32 bits. I have divided in bytes, each in different color. So what we will do, we will start with our result, which will be all zeros. So let's say all of these zeros. So this is our result. We will be modifying it. And what we will do, we will pick the last element or the least significant digit. We will check if it's 0 or 1. So what is the way to do that? Let's this number is n. So if we take n and 1. So what is this 1? This 1 is 31 zeros followed by last bit as 1. So if we take the AND of these two, if this last bit is 0, the AND will be 0. If this last bit is 1, the AND will be 1. So this can be either 1 or 0, depending on whether the last bit was set or unset. You can also use modulo. In modulo 2 is equal to 0 or 1. So this again can be 0 or 1. So we will take n and 1. If it's positive, that is if it's 1, then we will add 1 to it and then left shift it and right shift this one. So that way we will pick the first bit, set it here and then move it left, move it right. So let's run through this. So first bit is 0. So we make it 0. It's already 0. We will not add anything, just left shift it. So left shifting it will not change it. So it will remain as it is. Let me construct it from beginning. So left shifting it still remains 0. Then we right shift it. So what will happen? This left, this will be gone. This will be the least significant bit now, and 1 0 will be added here in this side. Then we see that again it's 0. So we will just left shift it. Then this is gone. Then we have 1. So we add 1 here and left shift it. So first we need to left shift the result. This is result. And then add 1 to it if the last bit is 1. So it's 1. So we left shifted the earlier 2 zeros and added 1 here. Then this is gone. Then again it's 1. So we left shift it and add 1. So this is the state now. And this one is also gone. Next again it's 1. So we add 1 and left shift it. Then this is also gone. Then 0. So 0 and we left shift it. So first we left shift then add. So either we add 0 or 1. Again this 0 is gone. Now this is again 0. So one more 0. Then 1. So 1 left shift and 1. That when we left shift, another 0 comes here automatically. But if it's 1, we also add 1 here. So this 0 turns into 1. Then we have left shift it. So this becomes 0. Then it's 0. So we don't add. Then next is 1. So we left shift this. So another 0 comes. Then it's a 1. So we add 1 here. So this becomes 1. Similarly for this, it will be 1, 1, 1. We will left shift 4 times and add 1 each time. Then for these 5, we will just left shift, but we will not add anything since these are not 1. So till here we are done. Let me redraw it, shift it left side. 0, 0, 1, 1, 1, 0, 0, 1, 0. Then 1, 1, 1, 1. 0, 0, 0, 0 and 1 more 0. Next we have 1. So we left shift. So a 0 comes here. Then we add 1 to it. So it becomes 1. So this is gone. Then 0. So you get the idea. This will build this in the reverse order. So 1, 0, 0, 1. Then 0, 1, 0, 0, 0, 0 and so on, all zeros. So now if you compare this, you see that we have 0 0 1 1, 0 0 1 1 1, and here it's 0 0 1 1 1. So 0 0 1 1 1, 0 0 1 1 1, then 0 0 1, 0 0 1, then 0, then 4 ones, 0, 4 ones, and you can see that if you read it in this direction and the result in this direction, it will be same. So this is one idea. So how we can do it? We can run a loop, initialize result equal to 0, then run it 32 times. So I equal to 0 to 32. First left shift result, and then if n and 1 is more than 0, that is it's 1, then result plus plus, and also n right shift by 1, and finally return the result. So this will work. Now let's see another idea. So here we ran this loop and it ran for 32 times. Irrespective of what is the number, it will always run 32 times. Here we will use bit masking. So what is the idea? This is again n, and the bytes are drawn in separate color. So first we divide it into two parts. Take the first 16 bits and next 16 bits and flip them using mask. So what will be the mask? So take if we take AND with first 16 bits as 1, so these are all ones, and then next 16 are 0. So what will be the AND of these two? It will be these 16 bits followed by all zeros, because AND with anything, AND of anything with 0 is 0. So this will be all zeros and this bit will be preserved. Now do it again. Next time, take the left part, all zeros in this mask. This is mask. We apply the mask, two different masks on the same number. First time, left 16 bits are 1, right 16 bits are 0. In the other mask, left 16 bits are 0 and right 16 bits are 1. So if you take the OR of these two after shifting, so take the AND of these two, what will happen? So let me explain this masking thing for one example, for one step, then the same logic will follow. So let's say this is the input n, and our first mask is all ones, or you can also write it as F. So this is in hexadecimal, so this denotes 4 bits, so this is 1 byte. FF 0 0 0 0, so this means 16 bits are 1, 16 bits are 0. 5 6 7 8 9 10 11 12 13 14 15 16, then 0 0 0 0. So this is mask 1, call it M1. Take the AND of these two, what will happen? It will be this blue region, so whatever is this blue followed by this yellow, and then all zeros. So this will be all 0 0 0. So this is coming from this. This is result 1. Let's call it R1. We will not do it separately, but we will do it in one step, but just for illustration. Now let's write the mask 2. Mask 2 is this one, 0x 0 0 0 0 F F F F. So this is M1, M2, 0 0 0 0, then 1 1 1 1. So result will be, result is the AND with n. So R1 is n and M1, R2 is n and M2. So what will happen? These things will become 0. So I am writing in blue this time. This left half becomes entirely 0. And in the right half, we have this white region. So whatever is this white bits, and then the green bits. Now what we need to do, make R1 right shift by 16. So what will happen? It will be all zeros here. So I'm writing R1, a bunch of zeros, 16 zeros, followed by this blue rectangle, followed by this yellow rectangle. So whatever was this region, this has come in the right part, and left part is all zeros. Similarly, R2 will be this white region followed by green region followed by all zeros. So whatever was in the right 16-bit comes here. Now take the OR of these two. So what will happen? R1 or R2. That will be this white bits. 8 bits are there. Then 8 green bits. Then 8 yellow bits. And finally 8 blue bits. And in the input we had blue, yellow, white, green. So here we have white, green, blue, yellow. So 16 bits have flipped. So this is how we can flip reverse bits, not flip but reverse bit in groups. So here we have first reverse this half, take this half as it is, move it here, take this half as it is, move it here. So this is the result after one iteration. So we have reversed in batches of 16, and here mask was 0x FF FF 0000, and second mask was 0x 0000 FF FF. Next what we will do, we will take this half and reverse these 8 bits. So this 8 comes here, this 8 comes here. Similarly this comes here, this goes here, and you can see the result. So here the mask was 16 ones followed by 16 zeros, and then we needed to shift, left shift and right shift in terms of 16 and took the OR. Here we will have 8 ones, 5, 6, 7, 8, 8 zeros, then 8 ones, 8 zeros. So here this 16 is further divided into 1 and 0. So if we take the AND with this and this, what will happen? These bits will become 0, these bits will become 0. Next time we take the opposite mask, that is 8 zeros followed by 8 ones, then 8 zeros, 8 ones, just like this. These masks are reverse of each other. So this time if we take the AND with second mask, then these will go away and these will remain, these will go away, these will remain. Again right shift one of them by 8 bits. So this white will come here, this blue will come here, and in the second result we do opposite, left shift by 8. So this yellow goes here, this green goes here, and then we take the OR. So these will be flipped and the result will be this. So now you see this 8 bits, rightmost 8 bits are now leftmost 8 bits, then followed by white, white, yellow, yellow, blue, blue. So we are making progress. First 16, then 8, and next you can guess we will reverse these 4. So this 1 1 0 0 and this will be 1 0 0 1. Similarly for this. So what should be the mask here? 16 1 16 0, then 16 0 16 1. Here it's in terms of batches of 8, 8 ones, 8 0, 8 ones, 8 0, and here it's the reverse, 0 followed by 1. So in this step the mask will be 4 ones, 4 zeros, again 4 ones, again 4 zeros, again 4 ones, and so on. So what is this? This is again F, this is 0, F 0. So you get the idea, and again F0 F0 4 times. And what will be the reverse? Reverse will be 0 0 0 0, 1 1 1 1, and so on. So 0F 0F 0F, and so on 8 times. So this will reverse in these 4 bits will be reversed. Next we will reverse in 2 batches. So we need 1 1 0 0, 1 1 0 0, 1 1 0 0, and so on. And the other mask will be 0 0 1 1, 0 0 1 1. And in hexadecimal we represent 4 bits by 1 letter. So what is this? This is 0 plus 0 plus 4 plus 8, that is, this is 12. This is again 12. So 12 is represented by C. So it will be C, 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 all C's. And what is this? This is a 1 plus 2, that is 3. So it will be 3. So the reverse mask will be 3, 3, 3, 3. So this will flip in terms of 2 bits. Then finally we will do it in 1 1 bit. So it should be all alternate bits, 1 0 1 0. So this 1 0 1 0 is 2 plus 8, that is 10. That is all A's are there, and in the other mask it will be 0 1 0 1, and this is 1 plus 4, that is 5. So it will be 5 5 5 5. So let's write the code for these approaches. We will mainly first write for this approach, which is simpler. So first we left shift result, then we added to it if the last bit was 1. Then we right shifted n, and finally return result. So let's try. And expected matches, so let's submit. And the solution is accepted. And it's 4 milliseconds. You can run it a few times, it can become 0 also. Now let's write this same thing in Java. First let me try this second approach, which is n equal to. So this here we will calculate R1, and that will be n and 0x f 0 0 0 0, and we right shift it by 16, and here what we will do, n and 0x 0 0 0 0 f, and this time we left shift it by 16. So this is M1, this is M2, this is R2, this is R1, and we are right shifting one, left shifting other, taking the OR. Next what we do, so this will be for 8, this will be for 4 2 1. Now let's fill these. Here it will be F0 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 and 0 F0 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 F 4 4 2 2 1 1, and here it will be C C C C C C C C. So we need 1 0 1 0. So 1 0 is 8 plus 4, that is 2. 8 plus 4, that is 12, which is C. And here it's 0 1 0 1. So that is 0 1 0 1, that is 5. So it's 0 0 1 1. So it should be 3. And again this works, so let's submit. And for those who are using C++, they can also try that bitset thing. So bitset will, if you write bitset.toString, it will return the string representation of these bits. Then you can always reverse the string using a reverse function. You need to pass string.begin and string.end. And once that is reversed, you can create a new bit set passing a string representation of a bits. So that will be the reverse bit set. And in bit set we also have dot to ulong or functions like this. You can explore it and then print the number. So you can try that thing also. So for Java, I will continue with this method. And the solution is accepted in Java. Finally, we will do it in Python 3. And in Java, I think there is a ready-made function. Let us try that. Reverse integer. And it works, you can see. Let's submit. So it is accepted also, but we generally don't use ready-made functions in these problems. And the solution is accepted in Python as well. And we are around 87%.